This is one of the longest devices I've ever had to work on. This is a big soundbar. Klipsch. Model number R-20B. Quite a basic unit, optical and RCA in. Quick look online suggests it could be as old as 2015. But, there's a bit of weight to it. Must be some decent magnets on the speakers. Looks like we've got 2 speakers on each side. I don't think there's any side-facing speakers. And I think this came as part of a set with a subwoofer, but I'm not sure. Anyway, this one makes no sound apparently. So it is 24 volt supply. I've got my signal gen. And let's see what happens. Oh, the red light just turned green. I wonder what that means. Is it booting up? I don't know. Put the volume down lowish. And let's go to 600 Hertz or something. On. Yep, definitely no audio. I've got a mute. And it's flashing to say it's in mute. Push volume plus. And the light flashes for that. Volume down, it flashes for that. It's not a button. Oh, input source, maybe that's something. No? If we don't, blue, is that Bluetooth? Let's have a look. Let's go Bluetooth devices, Klipsch. Okay, so we're paired. Cool. But we still have no sound. Alright, verified the problem. Let's crack it open. Looks like a bunch of screws around the center piece. I think the front grille pops off. It did have quite a bit of movement in it. So you might be able to pull the front grille off, or maybe push it out from the back once this is out, but we shall see. So I've only taken out the corner ones and the one in the middle. The others look a bit smaller. And there's 3 along the back there by the connectors, and it seems to have let go. And it's quite a nice little module, isn't it? Just the front panel connector and speaker connectors on the end, and we'll be able to get the module off by itself. So it looks like the other screws are holding the cover on, and then we've got the Bluetooth antenna just glued onto the outside there, so just want to be careful with that. Now, of course, before you do this, you have checked the resistance of your speakers to know that they're okay. I just did that. There's no point ripping this all apart if you just probe the end of the connectors there and find out that it's actually blowing the speakers. Alright, one long machine screw and a couple of differing length plastic screws. We'll keep them in order for some reason. Is that going to come off? Oh, okay. Here we go. So it looks like the cover's going to come off, exposing the guts of it. And we've got our switch. So we'll unplug that. Almost there. There's some more screws around the PCB, and then we'll be in. Well, it's covered in the yellow glue that loves to go conductive when it goes a darker brown color like over here. Let's just dig into that and see if it gives us a resistance reading of any sort. And There's a crunchy bit. No, it seems okay. Hasn't got there quite yet. So that won't be that. What have we got going on? I think that chip there is it's our amplifier IC. Not a hugely powerful device, I guess. It's quite small. There's not a lot on the other side. There's some shielding. From what I can see, there's nothing really under there. So that's our amplifier IC. That's our Bluetooth IC. Wireless audio module. I guess it connects wirelessly to the sub, perhaps. I don't know. So we've got our DC in here, and there is some kind of regulator there, I think. Possibly. It's either an inline inductor or it's actually a regulator for a different rail. Quite likely a rig. What's those caps? 10 volt. Yeah, there'd be a rig there. Possibly a couple of linear rigs. Little packages. Okay, I can see it looks like it's got a bit warm just down in this area. So let's jump under the microscope. Crispy. So crispy, I think it may have detached from the board. That little resistor there. Let's give it a bit of a nudge. 01B. Oh yeah, that's not even attached. You can see that wiggling. It's probably still alright as far as value goes. You can just resolder it on there. But it does go to... Where does it go to? I'm not entirely sure. Other side of the board, and then there, and there, and there, and there. That could be all our problem is. 01B is going to be, according to, let me find my sheet of information, 1K. Okay, it should be 1K ohm, according to a handy little website, kiloohm.info. They host a calculator, you can just put the code in. Survey says 1 kilo ohm. There we go. We shall reattach that and it'll probably work. This is going to be hard to clean off. It's been pretty hot, and solder tends to go like it can be like solid metal sometimes. It gets really hard to melt. Let's see what happens with this lot. Might get lucky. It looks alright. Shake off the bad stuff. $1K, there we go, that's what I've got. She's a little bit bigger, but that just means it'll deal with the heat a bit better, I guess. Here's hoping it's normal heat and not some other fault condition that occurs or is currently occurring. I guess we'll find out. And we've got lots of pad on the bottom there, so they're going to line up with the pads that we have. Just means it won't be able to wrap around the ends so much, I guess, but Now that trace from the left side down is extremely dark, but I have tested it and it is connected through. We also tested the transistor there and it is absolutely fine. So the only thing left to do, I guess, is plug it in. Just partially set up there. Let me just bridge the switch there. Just have to jump her across where the switch goes. Otherwise she won't turn on. And plug it in. It's got a red light as we had before. And you got to push the source button to turn it on. You can see there's a little green LED blinking down here. I'm just waiting for it to pair. Okay, it's connected now. I just had to tap on the phone. And if we go to our signal gen. Oh! We have audio. Aha! That was simple. I like simple jobs. I wonder if that's a common fault in all of them. I wonder how hot that component gets under normal run conditions. Let's have a look. Alright, so we'll turn that down. And we've got about 50 degrees, 70. Oh, let's see if we can hold this. We could put on a hotspot. There we go. 90 degrees. That's pretty dang warm. Well, it's been going for some time now, not a problem, so I guess that was it. Must be a common fault in these, I'd imagine. Flipping designs running components right to the edge of their limits, you know. 70 degrees, yeah, it doesn't sound like. I suppose a component can handle a lot more at reflow and that, but, you know, over time, obviously it degrades the solder on it and ends up like it was, so. These things, huh? Hope that helps you to fix your one. And thanks for watching.